Hello everyone, welcome back to another STEM Helps video. Today we're just reviewing on the differences between when you need to find the area versus when you need to find the slope. So let me give you an example. Let's say I have a velocity graph, and this is usually what any teacher will give you to confuse you, because you can find the rate of change, right? Change of velocity over time to get acceleration, or to get to position, you find the area under the function. So usually they will find velocity, and so I'll give you velocity. So let's have this weird velocity graph, right? I'll try my best to draw this. And so this is T1, T2, T3, T4. So this is going to be velocity 1, 2, 3. And so there's two questions. What is the instantaneous slope at t equals 2, and the other one is going to be position at t equals 3. Okay? So when we look at this, it would be a bit confusing, but again, use units. So when we find the instantaneous slope, first, what is a general slope? Just to recap, it is the change of whatever this is over time, and I'll write time here over time. Okay. So let's see what time is equal to 2. So this is going to be about right here. And so it says, okay, so let's start from 1 to 3, right? So the velocity is going to be 1 meters per second, and make a habit here. Let me do it over here where the problem is. So we have 1 meters per second minus 1 meters per second over, right, from 1 to 1 over a duration of 1 to 3 for over 2 seconds. Right? This is how we find the general slope, not the instantaneous slope. And so 1 minus 1 is 0. 0 over 2 equals 0 meters per second squared. So what does this mean? This means that it is not accelerating, right? Meters per second squared is acceleration. It's not accelerating. So because we're so lucky, because this is, even if we were to choose dots here and here, right, and find the slope here and here and find the slope, even here and here, find the slope, and if we were to really magnify it, if we were to just here and here, it would still be 0 meters per second squared. And just take my word for it. You don't need to take my word for it. Go ahead and do the math, and you'll see that, well, whatever point you choose, even if it's like 1 to 1.0001 divided by the time, it will still be 0. Because the velocity is the same, and it doesn't matter what the time from 3 seconds to 1 second. The instantaneous slope at t equals 2, so that means as you get so close that it's basically 1 point, the instantaneous slope, so y2 minus y1 over x2 minus x1 is equal to 0 meters per second squared. And once you get into higher level math classes, this is not what you see. You'll see something different. But just for the sake of the argument, the slope is equal to the instantaneous slope, which is equal to 0 meters per second squared. So what is the position at time 3? So we know that when we take the instantaneous slope or change of v over time, we get acceleration. And so it's saying that how do we get from velocity to position? Well, like we said in my previous video, we find the area under these parameters. This it looks like a trapezoid, and so we know the area of a trapezoid. And if you don't, I'll give you a refresher. So the area of a trapezoid is equal to height times the first base plus the second base, all this is height divided by 2. But look at the question. It's not at 1, 2, 3, 1, 2, 3, 4. It's not asking for position at time 4. It's asking for position at time 3. So we need to find the area at time 3. This is a weird shape, and we haven't really talked about this, and there's two ways of approaching this. We can either look at this from a trapezoid, right? Here's the first base, here's the second base, and we know the height. We can go for the trapezoid version, or if you want, we can divide it into two groups, this being a square and this being a triangle. You can go and approach it either way, and of course it's not aligned up because I'm not a good drawer, but I think that having one solid formula will just be so much better and less stressful. So let's go ahead with that. So what's the height? Well, 1, 2, so we have 2, and don't forget our units, meters per second, plus times base 1. Well, let's pick the top one, right? So from 1, 2, this is going to be 2 seconds plus 1, 2, 3 seconds over 2. And once we have this, we can cancel out all these. Let's simplify this so we can visually see all the units canceling. 2 meters per second, of course PEMDAS doing the parentheses first, times 5 seconds, and the seconds are going to cancel out, over 2, which is equal to 2 times 5 meters per 2, which is equal to 5 meters, and that is the position. Let's do another one, just a little short one. Let's say I have the acceleration graph, right? And this is you won't be able to solve because we don't have the a formula for this weird shape. Let's say I have this type of shape, right? And I want to find the velocity 2, 3, 4, 5 at time equals 5, right? So I want to find this entire area to get velocity at time equals 5. Well, we have to use calculus. So if you're in a calculus class and you know the actual function, if let's say this is going to be y equals 1/3 x to the third, you would be very easily solving this. But since we're not doing this, you will not see this on any test unless you're taking a calculus-based physics. You will only be looking at geometric shapes, which are very easy to solve. And I hope that's helpful.